nasa.gov track Artemis link, you can actually go on and see where Orion is, the Orion capsule is, how close it is to Earth, how close it is to Moon, and the next steps that it has to take in its journey before it comes back to Earth.
Awesome. And I just want to point out, I had a bit of trouble getting to YouTube. So thank you to all those folks patiently waiting in YouTube. To recap, Artemis is launched. And that's our big story for today. So let's get into it. If you have any questions about Artemis, the launch, or anything under the universe, put it into the chat if you're watching on Facebook. Or, well, if you're watching on Facebook, you can also ask a question there. And on YouTube, if you're watching on Telus Optic, you will have to come into YouTube on Facebook to ask live. But let's get into this big day, big evening on Tuesday evening. Artemis finally launched the biggest rocket humans have ever built.
Yes, and that's in terms of how much it can lifting capacity. In terms of size, it's a bit smaller than the Saturn V, but it is the most powerful rocket that we've ever made. We, the human race, I suppose, has ever made. And it was, I guess, a very fantastic launch. I did watch the launch video. They do have the video posted. The European Space Agency has it posted. And I always forget how loud these rocket launches are, like how loud it is. Like even the speakers get quite crackly at some points. You have to turn it down. It's a very powerful launch, and I'm envious of everyone in Florida who was there to watch it live. I would have loved to see it happen live.
Interesting. Yeah, I mean, like, any launch is just amazing. It's inherently dramatic, right? Like there's tension, there's a countdown.
Yes.
You know, there's a strange person kind of like listing all the things that are about to happen and are happening. And then there's always like the very strange like statement as soon as it lifts off.
Oh yeah, those always mute it. I don't know. As it lifts off, they've always got a little quip that they can say, you know, that I suppose people find very like it, I guess, but I don't like them, so I don't listen. I mute that part. But I do love the drama of a launch, especially, and the tension of the launch. You're exactly right. Like they had a few holds as well. There was tension about this one because there was another hurricane that passed through Florida. And the rocket was on the launch pad. It was on the mobile launcher. They didn't have time to roll it back to the vehicle assembly building. And so they really just had to hope that the winds wouldn't get too strong. There's a certain amount of wind that this thing can take. And it stayed below or just at the levels, the maximum that they would have liked the rocket to experience. And so it was all okay. There was a little bit of damage to the Orion capsule in forms of some of the caulking came off, the rubber caulking, but that's easily removed and easily replaced. And of course, some water into the arms that like hold the rocket in place before they come off in the rocket launches. So altogether, a successful launch. It got up there. But I think as one of the flight managers said that, you know, I won't be calm until that thing Orion capsule's back on Earth. It's got a long way to go before it comes back. This is footage from inside the Orion capsule. Of course, we have the Moonikin in there. I'm not sure. I think that's the Moonikin because there's two other that are just torsos from a few videos back. I think we talked about, and I really don't like those. They're just like bodies. It's very spooky. But the Moonikin in the Orion capsule, of course, being there to for NASA to figure out the G-force, the different forces, radiation being experienced that will be experienced by the crew of the future Artemis missions when they go up. And then this is an image from the Orion capsule. It's actually from how's it taking this photo is there's a camera attached to one of the solar arrays that it's able to take. So this was a photo it took as it was leaving Earth and on its way to the moon. It's over in this photo. It was over 80,000 kilometers away. And we get this what's become known as like the blue marble pictures, right? When you just have Earth in the foreground there. So I thought this was just a great photograph to show that's been taken from the spacecraft so far.
Yeah, absolutely. If you're watching, if you want to throw into the chat where you were and if you watched it live, Artemis on its way to the moon. So currently, as we see, going to the moon, but it's taking sort of these interesting orbits. So where currently is Artemis?
Well, I guess it's still called Artemis. It's still the Artemis mission. The Orion capsule,
the Orion capsule.
The capsule itself will take about 6 days to reach the moon. And what this link is for those who I think would have joined right when I was talking about it, it's a website you can go to where you can track Artemis, similar to how like the web had its deployment website. This is to track the Artemis mission, and it will tell you where the Orion capsule is, how far it is from Earth, how close is it to the moon, and what stage it is in. So right now, It takes about 6 days to reach the moon, a bit longer than we're used to with the Apollo missions, just in terms of orbits and stuff. And the mission length for this mission is to be 25 days, 11 hours, and 36 minutes. They have it like to the dot, which is great. It comes back. Hopefully, the Orion capsule will come back December 11th at 9:42 a.m. is when it'll splash down, re-enter Earth's atmosphere, and splash down. And what's great is that they have this graphic with so many little words on it that you don't really need to know right now. Just pay attention to the route, the green and the blue and the gray, I guess. Well, blue is the return when it begins to come home. So right now we are in days 2 to 5, which is the outbound coasting phase. So when it's just moving around, just kind of going towards the moon. So that's about step 9 in our big, or maybe a bit further out here. It is the Orion capsule here, so we're between stages 7 and 8, I guess, on this graphic. I guess I forgot the word for it. Days 6 to 9 after launch will be the transit to the distance. So as they're moving into what's called the distance retrograde orbit, so getting the capsule onto the path of the orbit that it wants to be on, right? Kind of moving it into the right spot for the right time. And then days 10 to 15 is when it's just in that orbit, when it's in the distance retrograde orbit, and it is orbiting the moon. At this stage, it will be just under 500,000 kilometers from the Earth as it orbits the moon. So it does get quite far out from the moon and then come in closer. And it'll spend about a week there at the moon, orbiting. And then day 16 is when it comes back. It starts its departure burn to leave that orbit and head on back to Earth. And days 16 to 19 are devoted to that, going through the space until day 20, where we get the return powered flyby, return transit, and then day 26, 25, we get the splashdown back in, which would be step 17 on this mission here. So the reason that in the upper corner we have this mission duration total 26 to 42 days is because the length of the mission would have changed depending on when we launched Artemis 1, when it was launched, just based on where the moon is, where the Earth is, and how the spacecraft would have to move, because it has to stay in the light, I think, at all times. It can't go into the dark for very long. So they have to keep that in mind as well. So this is on the shorter end of the mission, 26 days, but still enough time for them to deploy the CubeSats and gather all the information they need to know to see how the Orion capsule, fares during its travel.
Yeah, very cool. And I want to get into that, into some of those CubeSats in a minute, because there's some really interesting things going on with those. But just to lay this out, so Artemis 1 is essentially a test for the first crewed mission. So is this going to match the exact duration? Like, will astronauts be in the capsule for that amount of time?
No. No. They'll be in there for much shorter than what we're doing for Artemis 1. They want to take the benefit of like not having people on board to really, put the spacecraft through its paces, right? So it does quite a close approach. It goes very far out, testing, every which way they can while they have the spacecraft and the time to do so. When the people on board during Artemis 2, the mission duration will only be 10 days. It'll be a much, much shorter mission because people being in that cramped of a space for that long is not comfortable, nor would they want to do it, I don't think. I mean, yes, they're on the space station, but you get continuous resupplies on the space station, and you can still go to a separate part of it if you get in an argument. In that capsule, you are just stuck in there.
Yeah, so this is kind of going back to the space shuttle days when astronauts were inside, a small vehicle for a long period of time, because once they get to the ISS, they can at least kind of stretch out a bit, right? But on the capsule, like they're inside, a cramped space, can't be fun.
Yeah, it's very similar to like the Apollo capsule. Like the whole shape of it looks very similar to the Apollo command service module they would have had. Okay. And really it's like, well, there's only how big can we get that thing, while still being able to have enough fuel and all these different considerations. So it really is trying to get as much as you can into as small of an area as possible.
Right.
And they do that. So, but I don't know. It's great. It's very exciting. I'm glad that they were finally able to do it. And oh dear, what did I click? These next images I have, well, GIFs or animations, they might not play. Yeah, it doesn't look like they will. What they are, they're on from Wikipedia, from Fox, Phoenix, some username through Creative Commons, but it shows the path of the moon and in green, the Earth in blue, and Artemis 1 in pink. And it shows what the orbit looks like if you were at the moon. And then the next one shows what the orbit would look like if you were looking at it from the Earth. Oh, there it goes. This one's playing. So from Earth, this is what it looks like the Orion capsule is doing as it is at the moon. The one in green, which I thought was just very interesting because it looks very strange from how we would think about it, but it's all about frames of reference, I suppose. So the moon keeps going and it comes back. I don't know. I thought it was so neat.
Very, very
This
cool.
one won't play, but what can you do?
So to get back to those CubeSats, because those are actually really interesting in that there were some CubeSats that didn't make it because of so many delays. They had to be scrapped because they didn't have batteries. Is that right?
Yeah, so there's supposed to be more CubeSats in the beginning. Some people were not able to do it at all because some of them there were originally 13 chosen between the 2015 and 2017 time frame, right, when we were going to launch back then, before all the delays that happened. But 3 of them were not ready by the final deadline to process the payloads, and so some of them were pandemic related issues, some of them were battery related issues, and then a lot of the delays had led to some of the CubeSats having to be recharged and some experiments not being able to run the same on the CubeSats due to the delays on the launch pad and stuff. So once it was rolled back to the VAB, then the CubeSat teams could come in and take a look, but it was very much a will it or won't it scenario with some of those CubeSats. But there's some great experiments on the CubeSats. Some of them are lunar landers that will go on the surface and look. Some are just meant to fly or orbit the moon, but they have all different jobs and many different experiments from across the world, I think, predominantly American, but I think there's one from ESA, the Italian Space Agency, and JAXA all have CubeSats on board.
Excellent. And one of those CubeSats is Capstone, which I believe that you wanted to talk about. You've been anticipating Capstone. That was one of the highlights at the beginning of the year when we were talking about Artemis. So tell us all about Capstone.
So Capstone flew separately from Artemis, but it is a CubeSat. It launched itself, and on November 13th, it successfully completed the initial orbit insertion maneuver to put it into what's called a near rectilinear halo orbit, which I will talk about a bit later because it's a very interesting type of orbit, and why we're using it will come up a bit later. So we haven't talked about this in a while because Capstone had quite a kind of a tumultuous journey. There was a time when they lost contact with the spacecraft shortly after launch, and they had to reinitiate contact. There was time when it was not following its path properly. There was a problem with the thruster, so whenever it tried to thrust, it pressurized itself and moved itself off course. So there was quite a lot of different complications that arose with Capstone. So when it finally got into orbit, it was a big relief. So Capstone is a type of CubeSat, which is just a very small satellite. This one is about the size of a microwave. Its purpose is to test the stability of that NRHO, that near rectilinear halo orbit, and to test and validate new navigation technologies that different places have come up with. And it will orbit the moon for at least 6 months. So it'll be there when the Orion capsule comes by, right? So there are lots of things going on at the moon now. Capstone is just a very long name. It stands for a very long name that I won't say because I will probably, trip over my words. And it's going to do all these different things. The navigation technologies for me is particularly interesting because typically how we monitor spacecraft is it talks to Earth, right? We track it from Earth, and that's how we know where it is in space and how we're able to tell the spacecraft where it is in space. Instead, what Capstone will do is it's going to communicate directly with the Lunar Reconnaissance Orbiter. And the data used from that crosslink, from the Capstone talking to the LRO, it will measure how far it is from the LRO and how fast the distance between the two of them change because they're both orbiting the moon. So it will talk to the LRO, they'll both orbit, it'll track how fast the distance changes, and that will tell Capstone where it is in space, as opposed to it having to talk to Earth and do that work instead, relying on Earth tracking. So it's a new way of monitoring spacecraft and having them know where they are in space without using Earth as a frame of reference, which I thought was very cool, and I hope it works. But here's this new rectilinear halo orbit. And what I've done is I've split it into 2 because they're 2 different orbits put together, is how I understand them. And so in a near rectilinear orbit, parts of the orbit are much more curved, right? So orbits can be like a circle. They're typically ellipses, so very squished. And so in a near rectilinear orbit, parts of them are more curved and some parts are like very straight or less curved than it would be if it were a traditional elliptical orbit. So it's just very much a very odd ellipse. A halo orbit is a periodic three-dimensional orbit that is going on near one of the L1, L2, and L3 Lagrange points. So we remember Lagrange points from Webb. It's at the L2 Lagrange points for the Sun-Earth system. Capstone will be at the L2 point of the Earth-Moon system. So if you were to remember the Webb diagram, which I forgot to put in here, it would be just on the other side of the moon. It'd go Earth, Moon, Capstone is where it will be orbiting, which is very cool, a fun little interesting orbit. And the reason we're using that type of orbit is because it's the proposed orbit for what is known as the Lunar Gateway or the Gateway, which is what will be, someone I think said to me, oh, it's the ISS of the moon. And I was like, yes, but no. Like, yes, but no. It's very similar. It has similar purposes. You know, it's a human tended but small space station. It's like 1/6 the size of the International Space Station. And it's also designed to enable deep space exploration. So kind of it's been referred to as a staging point for Mars missions. So you would go stop off at the moon, do whatever you need to do, head on to Mars. And so it's like one part human habitat, one part, you know, docking station, one part refueling station, one part science lab. Like it kind of does a lot of different things, but it will use that NRHO. And so we've never tested an NRHO orbit before. And so that's what Capstone's doing. It's testing that orbit before we start building the gateway in that orbit to make sure that all of the math they've done and all the theory holds up for that orbit.
Very, very cool. I like to call the Lunar Gateway the sequel to the ISS. You know, it's its own thing. It's different. It's advancing in the story of humans going to space and now going even further to the moon. So this is great stuff. So now we're finally on our way. What's the timeline for Artemis 2? Are we still on track?
I mean, they say we're on track. I don't know if I believe them. They say NASA is their goal is no earlier than May 2024 for Artemis 2. And that will be when the astronauts just go around the moon, that 10-day mission around the moon. One of them will be a Canadian astronaut. We still don't know who. I really want to know. Whatever. And then Gateway is supposed to come November 2024, parts of it. The first two parts of it are supposed to launch in November of 2024. The power propulsion module and the IHAB, which is like the habitation module, are the ones that are supposed to launch in November 2024. What's interesting is Gateway can kind of work independently of Artemis, right? It doesn't need the SLS to launch. It'll be launched using a different space vehicle. So even if Artemis 2 gets delayed, the Gateway building will still may still go ahead. It's not dependent on Artemis 2.
Okay. Well, we've got about 10 more minutes, folks. If you're here on YouTube or in Facebook and want to get in on some questions on all of this stuff that we're talking about, so much to get to. Well, I'm going to also get to a special event that's happening a little bit later tonight. So there is one sort of tangential off-topic question that we did get from YouTube, and I have no idea if this is something you might be able to answer, but kind of intriguing. The Bighorn medicine wheel, is this something that you're familiar with, Marley?
No, but I will look it up. Oh, that's in
it's in Wyoming.
Yeah, I don't know what this is, but it looks very cool. But I don't know what that is. Or what was there any more to the question, or was it just Bighorn medicine wheel?
Well, the question is, what do the 28 spokes like? What would they signify? Because obviously, this is a Native American circle of stones, and there are many, patterns of stones all around the world that have some astronomical significance. Some are not as clear as others. Some were sort of sundials or some sort of marker of time. But this particular one was said to predict astronomical events. I'm not super familiar with it, and I'm assuming that you're not either, but I think we're both I'm intrigued now. I want to learn more about this.
My first thought was it being 28 days. I was like, oh, maybe the moon, but the moon is 29 or 29 and a half. So it's a bit off for the moon. But I've never heard of this what would you call it in terms of landmark before. So very interesting though. I do love this feature. There's a lot of these around the world, right? Of different peoples having built something of significance, and then us not knowing what that significance is anymore, and trying to work backwards to try to figure out what it was. But I don't know. It's a shame that if that knowledge has been lost, that it is lost, right?
Yeah.
I would love to know.
Well, you know what? I'm definitely going to ask Shandine, who's going to be doing our event with us on December the 8th. And this is going to be an event that we're going to be doing about Indigenous astronomy. So Shandine Pete is a Salish Salish person who is going to be who has been doing a whole bunch of research on how Indigenous people look at the nighttime sky, and he's finally moved out here to the West Coast. He's an adjunct professor at the University of British Columbia. So I'm going to ask him this and see if he's heard of the Bighorn medicine wheel, and if that has any significance in his findings. And that is December the 8th. Check out our website. We're going to be putting out info on that very soon. Another question that just came in from Fair Marino. Speaking of launchings, were there any improvements, commitments to address Starlink satellites complicating Earth's observatories?
Oh, I haven't heard anything about if there's been anything done with communicating with Starlink and or SpaceX, whatever, and how it affects Earth's observing on Earth. I know that it's still deeply frustrating for some astronomers to have to deal with this problem. It does get quite frustrating. I know that, but I haven't heard if there's been any further communication about what can possibly be done. The largest part I think that people find frustrating is when the satellites are first launched, they're so low in orbit, right? Like you can see them with the naked eye when they pass. It's a huge train. And the way astronomy observation works is that you have to stare at one area and track one area of the sky for a very long time, like over, up to hours, or if you want to do deep observations, up to weeks or days, right? And so you're staring for so long. And then even though those satellites pass through the field of view quite quickly, that's still at the end of the day a significant chunk of information that's now been lost, right? And so that's the crux of the frustration, is that, well, now we have these things moving in and out of the field of view. Our data is not a full picture anymore because now there's this chunk of interruption that can't be used. So much noise. But I don't know of any like negotiating talks, I guess, if those have opened up again, or if there's more to be done about it. I don't think there is, but
I think that probably what's going to happen, because the Starlink satellites are not like forever, right? Like they're not meant to be up there for a long period of time. So whatever the next iteration of them are going to be, hopefully we'll have a little bit more consultation. I think when they were proposed, they sort of caught everyone's by surprise, but I think a lot of things in that realm of orbiting satellites and space debris, this is all a burgeoning field that more and more people are now paying attention to. And now you have agencies like the Space Force that are trying to monitor that a little bit more. But then you have global issues. We have the Chinese booster that just fell down into the ocean the other week. So lots of things. And of course, with Starlink, if you're frustrated with something that Elon Musk made, get in line.
Join everyone on Twitter. Yeah. No, I know that at one point Starlink did lower the brightness of their satellites to try to reduce the concerns astronomers had. I don't know how much it helped. I didn't really look into it because I wasn't doing any active observation, but I imagine it might have helped a little bit. But at the end, when you have something that big, a telescope that large, right, that the astronomers use, especially if you're doing optical observation, those mirrors are quite big. It collects a lot of light, and things that are very dim get very bright. So even the satellites could still appear bright when they pass in the field of view. But really, I don't know. Hopefully the next iteration, takes more into account, but who can say?
I've never seen them myself, but if you've seen these rows of Starlink satellites, and maybe you didn't know what you were seeing, because it would look kind of odd. I can imagine, I've seen videos of them going across. They do sort of look they do look like an artificial craft of some sort, right? It doesn't look unnatural,
Yes.
like a meteor or something streaking across the sky, but it does look odd because of the very straight road that they go across the sky. So if you've seen it, throw in the chat and just maybe describe what it looks like to you. So the last few minutes, Marley, just wanted to throw out a few tidbits here. Of course, tonight we have a very big event in the building here at the Space Center. We have our first 19 plus event, Cosmic Nights, officially back. These were our really fun nights where we would serve beer and wine, and we are bringing back original Ask an Astronomer host Rachel Wang. That is going to be our special guest with you, Marley, in the planetarium, talking about quantum cosmology. This is going to be really fun, and the fun part is that we are continuing to do hybrid events. So if you're someone that can't make it on site and just want to tune in to Marley and Rachel's presentation, you can get a ticket. Go on to our website, spacecenter.ca, to get that ticket for tonight. And there's still tickets left. Not too many, actually. We've been selling a lot for the in-person event, so you can come and watch and have a nice beer and wine. It's so wonderful to be social again after being cooped up. I'm really excited for these events. And also, we've been also brainstorming for what we're going to be doing here on this channel for next year, possibly maybe even moving the time to a different time. If you have some ideas of a time of day, if you want to tune in live, that might work a bit better for you, or think about maybe moving it a little bit later, maybe after school sometime, send us an email. You can info@spacecenter.ca, or just throw a comment here into the chat on maybe a time, maybe a day that might work. You know, it's all up there. We're kind of just brainstorming, doing what we want to do. You know, this is our fun. We are part of this little community here on YouTube. Space stories, asking questions. It's been fun, and I'm getting excited for tonight. What are you looking forward to tonight, Marley?
I don't know really. I'm excited for it, but I don't think I have a specific part about what I'm excited for. It's an event. I got to make sure everything works. I think once I know everything works, I'll be more excited.
Exactly. Yeah, we've got to make sure everything is running smoothly, which is what I'm going to do right now. Get ready for tonight. All right, folks, that is the end of another episode of Ask an Astronomer. Thank you, Marley. Thank you to all of you watching on YouTube, on Facebook, on Telus Optic. We will be back in 2 weeks on December the 1st. Wow, it's already the end of the year. Till then,
Oh boy.
clear skies.